If two shapes are exactly the same, what's the big C word we've been calling them? Very good, they're congruent. But sometimes two shapes aren't the same. They're like these. They're different sizes, but dang it, other than that, they seem pretty darn the same. So for those shapes, we call them similar. Similar. Similar polygons. Similar polygons have exactly the same angles. The angles are the exact same, but the sides are not the same. They are proportional, which is what Blake set up. He set up a proportion. If two shapes are similar, the angles are congruent, and the sides are proportional. Now, what the heck is he talking about, proportional? I'll show you in just a second. But the angles will all be the same as their corresponding angles. Here's a similarity statement. This little squiggly squig, that is a similarity. It says ABCD is similar to EFGH. And just like a congruent statement, the order gives you everything you need to know. If they give you a similarity statement or a congruent statement ever in the directions, shame on you for missing any part of the problem, because everything you need is right there. So 5 people will write things down. Matt, if I said ABCD is similar to EFGH, which angle is congruent to angle C on the other shape? G. Very good. How'd you get that? Very good. They're both the third one. They're both the third one. If I said angle D is congruent to what angle, Cameron, what would that be? Very good. Same exact spot in the similarity statement. Now let's go one step further. You know that the sides are proportional, which means each side has a corresponding proportional side, just like the DOM. So, Brandon, which side is proportional to BC on this shape? BC. Very good. Same. Now you can look at the shape. Sometimes they're turned and you can't tell. Look at the bloody statement. BC are the middle two letters. FG are the middle two letters. What about AD? What's AD going to be similar to, Clay? EH. Very good. First and fourth. First and fourth. Very, very good. Questions about what that is saying before we go on to some examples? Similar. Now, let's go back to the DOM real quick. So in the DOM, these are similar triangles. Now again, I told you that the sides are proportional. That means this. Which side does ED go along with on the other one? In M. So 9 over 12 equals, which side does DF go along with? MP. 12 over 16. Is that a true statement? Is 9 over 12 equal to 12 over 16? How can we solve a proportion? You could just simplify it. Or what's another way you can solve a proportion? Cross multiply. 9 times 16 is 144. 12 times 12 is 144. Bang. They are the same, so you know we're right. And lastly, we found 15 over 20. Do all three of those reduce to 3/4? Yes, they do. All three of those reduce to 3 over 4, which means that this is a similar polygon. These are similar polygons. And that 3/4 is called the scale factor. The scale factor, that's the ratio that relates the two shapes. This one is 3/4 of this one for every 3. And that's what Brandon was saying earlier. He noticed this one went by 3s, 9, 12, 15. And this one goes by 4s, 12, 16, 20. The scale factor for those two polygons is 3 to 4. Remember those ratios that had colons? So, let's look at another one. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Okay. Are they similar? What's the first thing we're looking for? Let me back up. What did we say had to be the same? They have to have all what kind of angles? They have to be they have to be congruent, and the sides have to be proportional. That's what we're checking. So, let's look at one angle at a time. Is there an angle over here that's congruent to angle F? What is it? Very good. One loop, one loop. What about G? Why don't you just take this? What's G congruent to? H and J. So they all have a corresponding piece, right? That part's good. We're still not done yet, though. Now we have to show that the sides are, big P word, proportional. Very good. So, here we go. Now, let's go ahead and put those angles. We are thinking, by what Sage just told me, F went with Z, G went with Y, H went with X, and J went with W. That was the order she gave me. So we are thinking this is going to be the case, but we still have to see that the sides are proportional in order to say that. So FG goes along with which side? All right, so I'm going to put FG over ZY. GH goes with which side? YX. So it's 24 over 30. Let's see. JH goes with which side? WX, 12 over 15. And FJ goes with ZW. Are those all the same fraction? They may not be. Do they reduce to the same thing? The key is to find what you have to divide them all by. Let's see. 20 over 25. Who can tell me what that reduces to? You can put it in your calculator. 20 divided by 25, math, enter. Yes, sir. 4/5. What about 24 over 30? Who can tell me that one? 4/5. Well, we have to check all of them. If one of them is different, then everything is off. What about 12 over 15? 4/5. And 16 over 20? If they all, dang it, if they all reduce the same, then you have similar polygons. What is the scale factor for these two polygons? 4 over 5 is what it reduces to. Very good. Now, what did it ask us for? It asked us for the scale factor, which is 4/5. And it asked us for the similarity statement, which is right there. Order matters. If you mix up even one letter in either of those and they still don't correspond, then you missed it. Order matters. Questions about what you're going to be asked to do on those problems? No? Great. Well, in that case, let's jump ahead. Now with this one, it's telling us they're similar. Oh, this looks just like the DOM. But here's how you're going to solve them today. Now, some of you use different methods. Here's how you're going to solve it. If they're similar, you can do one of two things. You can find the scale factor. So I believe we said the scale factor on this one was 3/4. And then you find the two pieces that you need. You need to find X. Which piece does X go along with? And you can solve it proportionally. 60 equals 4X divided by 4. And X is 15. X, 20, scale factor. Or, if they're similar, just pick any two sides that you want. Like, what if we'd said, well, I'll choose the 12 and the 16. And then you obviously have to go back to the two you're actually looking for as well. X over 20, and you'll still get 15. So it doesn't really matter which way you do it. You can use the scale factor, or you can use pairs of corresponding sides. Questions about how we're going to solve that? Good. Try that one. Find X. And I want you to give me its scale factor. Find X and find the scale factor. Cool. And I want that scale factor reduced. Solve for X. Found an orange pen. Unbelievable. I actually had an orange pen and I can't find it. What's over here? Where'd you get that pin, Donovan? Yeah, right. First things first. Who can tell me what my scale factor is? Trip. Very good. Which two pieces did you put together to use to get that? Did you just put it in your calculator, math, and enter, or did you reduce it yourself? Okay, that's fine. Or it's not cheap. I don't mind if you just punch it in your calculator. And once again, I'll show you how to do that. Now, obviously, you don't have to do all this. But if you're looking at your calculator, now you could have done the 16, so 6 over 9 too. Divided by 22.5, math, enter, 2/3. And that is your scale factor. 2 to 3. Now, there were multiple ways you could have solved this. Amber, how'd you solve it? Sorry? You Dan Hobbit. Caitlin? That'll work. That'll work. You could have also done 14 over 9 equals 14 over x. No, I'm sorry, I said that wrong. 6 over 9 equals 14 over x. You could have also done 2 over 3 equals 14 over x. You could have used the scale factor. But regardless of how you did it, you should have gotten... Oh man, I don't know what this is in my head. Hold on, I can do this. 315. Divide by x, or divide by 15. What'd you get, 21? 21. 21. Questions? All you have questions? Any of them? Great! Then I'll call in 2 different people this time for this one. Solve for A. Find the scale factor. Solve for A. Find the scale factor. You pick on 2 different people. What's that? Is that beatboxing? Who's he going to call on? I'm not going to take volunteers. Are you crazy? Jasmine? Okay. Finish writing it down and then tell me what the scale factor be. What be the scale factor? You want to take this one? Isn't. Close, but you need 2 numbers for a scale factor. I'll wait for Jasmine. Scale factor. No, well, I bet they told you 9 to 10 would be my guess, if someone told you. Which I could see how that could be construed for 19. That's an excellent question. Are these similar? Don't mind the circle here. Yes, if it tells you that, they're similar. Now, good question. Elon, pick any side on the left-hand triangle. Pick one. I don't care. I like that 45 too. Now, of that 45, which side do you think goes along with that one from the other triangle? 50. Divide them in your calculator. 50. Enter. Now hit math, enter, enter. Math, enter, enter. What does it tell you? There you go. That's the scale factor. Now, Jasmine, what did that give us for A? 36. That's what I got as well. So, you set your scale factor equal to your side over 40. Cross multiply. That's 360 equals 10A. Divide by 10. And you should get A equals 36. Very good. Yes. Okay.
So, like, you got the 9 over 10.
Steve?
So, the first fraction you get is supposed to divide it. Correct?
Come again?
Like, okay, you get your first fraction, you divide that instead of, like, cross multiplying.
For the scale factor?
Yeah.
Yeah, you just reduce it.
Okay.
Yeah. Yeah, for scale factor, you just reduce. And then you don't start cross multiplying until you solve for a piece. That was a good question. Other questions? Okay. Well, let's look at one other thing. Who can tell me what a perimeter is?
The area around
the outside of the area.
I think you're all saying the same thing, just in different ways. You're right. It's the total distance around, perimeter. What would the perimeter be on RST? Let's add it up. Tell me what you get for the perimeter of RST. 8.
108.
Oh. What's the perimeter of XYZ? Dude, you're so fast. 120. Nah, really? You just did that. Okay, now, somebody punch that in the calculator and hit math enter, enter. Tell me what you get. Holy mackerel! You do! You get the same exact stinking scale factor. That's what our next piece of notes is. You do not have to write all that down. All I would write down, if I were you, is that Theorem 6.1 states that the perimeters of similar polygons is equal to the same scale factor. That's all I'd write down.
Why would we ever need to do that?
What do you mean?
That's wrong.
There's a chance that in a proof, like on a test, there might be one that says, how do you know that the perimeters are proportional? And you do Theorem 6.1. But most of the time you don't. Once you find the scale factor and you know they're similar, just apply it for the perimeters. Now, you're going to have problems like that today, where it's going to be like, what's the scale factor? You're going to find it. Then it's going to say, what's the perimeter of the two? Well, you could always just add them all up. You don't technically have to do it this way. But what if you have like a 48-sided figure, and it only gives you one of each, and it tells you they're similar? Well, instead of solving for all the other 47 and adding them all up, you could just use this if they were to give you one of the perimeters. So that's the point. Questions about what this is saying? Okay. You really don't have to write it down. Really, you just need to write down. I would always reword these into whatever makes it sound the best for you. Because if I were to write these down verbatim, I wouldn't have any clue what they were. Touche. Touche. Here's an example, while he's writing this down, here's an example of when this could be helpful. I'm going to tell you that the perimeter of this one is 20, that this side is 3, oh, that's a horrible one to choose, 4, and this side is 10, and I want you to find the perimeter of this guy. What's the scale factor for the two shapes? It's 4 over 10, which reduces to 2 over 5. Now, if they only give you one set of pieces in the perimeter, don't bother finding the rest of the pieces. The same scale factor is in place. So 2 over 5 equals 20 over x. That'd be 2x equals 100. And what is my perimeter going to be? 50 when you divide by 2. Very good. That's how this can help you. And yes, I'm going to ask you for the perimeter on all the next few examples. Questions? All right, here we go. Find the scale factor. Find the scale factor, find the value of x, and then find the perimeter. Yes, but again, you don't have to find every side. You're going to do it the exact same way. Again, they're telling you it's similar, so you don't have to show anything. If they don't tell you it's similar, you'll have to first show that it's similar. So, find the scale factor, solve for x, and find the perimeter of A, B, C, D, E. You think so? Who can tell me what the scale factor is? Very good. 2/3. Scale factor. He took 10, he took the 15, and he reduced. 10 over 15 reduces to 2/3 in your calculator. Because those are the only two it gave you. Where? The x? This one? That's an 18, yes. Now, who found my x for me? Did Starla find my x for me? Aww. Aww. Amber, did you find my x for me? At least you're honest and straightforward. You didn't waste my time. I appreciate that. No, I didn't. And I appreciate that. Cameron, did you find my x for me? But Cameron, I'm betting you can tell me how to find the x. What's my scale factor, Cameron? What's that? 2/3. Very good. Now, does my x go with the 2 shape or the 3 shape? Which one's the smaller? What? Very good. Which side goes along with x? Very good. Now how do I solve a proportion? There you go. 2 times 18 equals 3 times x. Divide both sides by 3. And x equals 12. Got it? Hey Brandon, how can I find the perimeter on the right-hand one? Now don't overthink it now. Just the right-hand shape. If I asked you to find the perimeter, could you do it? Yeah. Yeah. Add them all up. And so who did that? And who can tell me what that just what that perimeter is? Yes. 69. Hey, Drew, you should have got that one. 69. Now, if that one is 69 and your scale factor is 2/3, how can I find our new perimeter? I can tell you want to tell me, Malik. Use your words. You do it the same way you find a shape. Scale factor equals the perimeter I'm looking for over the perimeter I know, as long as you're still going in the same order. Notice, small to large, small to large. Cross multiply. 3p. 2 times 69. Divide by 3, and what did somebody get? Thank you, 46. That is the perimeter Not the area, the perimeter of the first one. We were a little sluggish on that one. Yes, you were, and I appreciate that. So we're going to try another one. Same thing. Oh, except this one. Yes, this one. The only thing I want is the scale factor. Notice I didn't even ask you for a side. And the perimeter of the small one. Perimeter of this one. I want the scale factor and the perimeter. What are you telling me right now? What is the scale factor? How in the blazes did you get 2/3? I'm not saying you're wrong. How'd you get it? Very good. Now this one was tricky because you had to kind of turn it in your head and think which piece goes with which piece. The slanted side does go to the slanted side. Now you went this one to this one, that's fine. So you went 8 to 12. You won't always just go with the smaller one first. Just whichever order, as long as you're consistent. 8 to 12, which reduced to what? What'd you tell me it was? 2/3, thank you. That's your scale factor. Scale factor. How did you set up to find the perimeter? And what did you get when you added it? 45. Very good. Very good. Very good. Questions? Scale factor, proportion. You use this all the time, okay? If you're ever helping someone carpet a room or do anything at all inside a house, you probably use scale factor. You have to use tape measures, you have to think about it, you have to do it. Yep. Okay, so anywho, here's this, and I'm going to pass out a worksheet which you will staple to the back. Yes.
I go keep those shirt on so that
Hold on. Yes, here. Now please follow instructions. Staple to the back. Of course, that's assuming I ever pass out your worksheet.
You don't have to.
Oh, I will. Don't you worry. Maybe we will.
Oh my God! I'll cry. Oh, you had to get it down. He died? Spoiler! When I had class, that was funny. We watched the whole season of the show. 5 episodes, 7.5 hours long. We got to the very end about the New Year died, and I told him that he died, and it was so fun to do. Oh, and I didn't really like that. We were walking in Walmart, and jumped in the old woman show. Oh, I was told to see the old lady. And I was like, I don't know. What show did you watch? Sherlock. Did you watch Sherlock? I watched some of it. I mean, I personally like it. It's like you can't get into it. My show. Just hold it on. Oh, I watched Walking Dead. That is a good show. Yeah, I love it. I've seen every single one so far. I haven't seen one from yesterday. I haven't seen that one. It's recorded. Mine too. My wife would watch that. Oh, then we actually like write down. On 3 through 5. On 3 through 5. Does everybody have this written down? Excellent.
Well, it's on the backboard anyway in red. 3 through 5, you actually have to do this. You have to list the angles that are congruent and the sides that are proportional. That's what you have to do. You don't have to solve for anything. You have to list on 3 through 5. All you have to do is write the list that's right. Oh, because the sides aren't congruent. They're proportional. Don't forget, the sides are not congruent. They are proportional. So instead of writing that they equal each other, you have to put it over the one that they correspond with. What? So like this, these two are similar. Therefore, what two pieces go together? A, B, and E, F. So you put them up as a fraction. A, D, and E, H, fraction. B, C, G, H, fraction. B, C, F, G, fraction. Yeah. I'm sorry?